Hey guys, welcome back. So our next lesson is the second part of the first review. And we're going to just go ahead and dive right in. So make sure that you have these notes printed off of Google Classroom so you can follow along. And I tried to make it easier for you guys by having the notes labeled with the date that they're being assigned, as well as the title and the page number. That way it's easier to kind of figure out like what you need to turn in and where you need to turn it in on Google Classroom. So let's go ahead and jump right in. So our first set of problems is translating equations and inequalities. So it's going to give you what the equation or inequality is in terms of words, and you need to write that as an equation or an inequality. So the first thing we're going to look at is number one. It says the quotient of twice a number and 7 is 20. So the fact that they're saying that all of this is 20 means we have an equation. So there's going to be an equal sign here, and it's going to equal 20. So that part we know for sure. The other side says the quotient. Well, quotient should be a keyword for you that you have to divide. So let's do a division. And it says the quotient of twice a number and 7. So that means that you're dividing twice a number. So 2 times a number, you're dividing by 7. And that's all going to equal 20. And I wrote that really far apart. So let me see if I can just move this over a little. Yep, there we go. Okay, so let's move on and do 2, 3, and 4. And I didn't leave any of these for you to do yourself. So if you want to challenge, you can pause the video and try these and then see if your answers match my answers, okay? Okay, 5 less than the product of a number and 3 is 14. So we have another equals. And 5 less means I'm going to have some quantity and I'm going to subtract 5 from that. And that quantity is going to be the product of a number and 3. So product means we're multiplying. We're multiplying 3 and a number. So 3 times a number. We're taking 5 away from that. And that's going to be equal to 14. Okay. 3 and 4. So number 3 says 7 times the difference of x and 4 is negative 10. So this means that 7 times the difference of x and 4. So x is some number and 4 is what we're subtracting by. Basically what this means is that you're going to take 7 and you're multiplying it by this whole quantity, which is the difference of x and 4. So when you have a quantity like that, you can use parentheses. So that's the difference between x and 4. So you're going to take 4 away from x. And all of that equals negative 10, they told us, okay? And we have number 4. The product of a number and 4 increased by 1 is at least 7. So this is the one that's going to be an inequality. And I know for sure because of this keyword right here, which is that it's at least 7, okay? So that means that all of this, I'm going to highlight it, all of this, the product of the number of 4, blah, 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 all of that is going to be at least 7. It's going to be 7 or greater. So it can be greater than 7 or 7, but it can't be less than 7, okay? So the product of a number and 4. So 4 times a number increased by 1, meaning we're going to add 1 to that, is greater than or equal to 7. And the reason I'm choosing this is because this symbol represents that this whole quantity over here, 4x plus 1, is greater than 7 or it equals 7, which means that it's at least 7. It's not less than 7. Okay, the next topic here is about equations. So we're just solving some pretty basic linear equations here. On number 1, we have 18 equals 3 minus 3a. Remember, when you're solving an equation, the goal here is that you're supposed to try and find a way to get the variable that you're solving for completely by itself on one side, okay? So the a is already on the right side here, so I'm probably going to leave it there. But first I'm going to use opposite operations to move some stuff around. So I want to get rid of this 3 first. I'm going to subtract 3 from both sides. And I get 15 equals negative 3 times a. So if negative 3 and a are being multiplied by each other, the opposite of that would be division. So if you divide them by negative 3, and you have to do that on both sides, this will cancel out, and what you'll be left with is 15 divided by negative 3. Well, that's negative 5. I'm going to draw an arrow because I ran out of room. Negative 5 equals, and all you have left over here is a, so you have solved for the variable. You can always go back to, and you can take this value, negative 5, that you just solved for a, and you can go back to your original equation and plug it in and see if it works, if you want to check your work. Okay, so 2, 4, 6, 8, and 10 are for you guys. I'm doing 1, 3, 5, 7, and 9, so I'm going to just keep chugging along here. Number 3, first things first, I'm going to use opposite operations to take 17 away from both sides, and that's going to cancel out. And what I'm left with here is 3/4 times x equals, and the difference between 23 and 17 is 6. Now, how do I get rid of fractions? And you're going to have to kind of search your brain and go back and think back to when we did this because it was a while ago. But remember, you can get rid of or cancel out a fraction by multiplying by its reciprocal. You flip the fraction and multiply that by both sides of the equation and it will cancel out. So let's do that. We're going to take this whole side of this equation and multiply it by 4/3 because that's the flip. And then on the other side, we're going to do the same thing, multiply by 4/3. Well, I'll switch colors for this so you can see, but the 4/3 and the 3/4 will cancel out over here on the left side. So all you'll have left here is x equals, and we just need to figure out what is 6 times 4/3. Well, 6 times 4 is 24, and 24 divided by 3 is 8. So my answer here is going to be 8. And I can always go back and plug this in to my original equation and see if I can get the answer that way, okay? Okay, so next problem. We have a little bit of distributive property on this one that we have to do first before we start getting stuff by itself. So this is going to be taking this negative 6 and multiplying it by w, and then multiplying it by negative 4, okay? And then the other parentheses over here, I can do it at the same time. I'm just going to do, we zoomed in like way too much there. The other parentheses that I'm going to work on is going to be 2 times w and then 2 times 9. So let's rewrite this equation. It's negative 6w plus 24. Okay, because 6 times 4 is 24, and negative times a negative makes it positive. Okay, plus 8w. And then on the other side, we have 2w plus 18, because 9 times 2 is 18. Okay, we do need to combine some like terms here. On the left side, we can combine negative 6w and 8w. When you combine those together, I'll use a different color to show this, but these two things right here on this side are like terms, so you need to combine them. And what you end up with when you have that is a positive 2w, and you still have a 24. And this is a positive 2w plus 18. Now, I already see a problem with this because, think about it, these two things are the same. The 2w, those are the same, those are the same thing, okay? So, if the quantity that is 2w is the same on both sides, then 2w plus 24 can't be the same as 2w plus 18. Think about this. If w was 0, okay, if you plug in 0 for w, this is going to be 0, and this is going to be 0, and all you'd have left is 24 equals 18. That doesn't make any sense. So there is no solution to this equation right here. There's no value you could plug in for w that would make the equation true. So this is no solution. And I mean, you can solve it too if you want to other ways, like you can subtract 2w from both sides. So this will cancel out, but guess what? This will cancel out as well. And again, all you'll have left is 24 equals 18, which is not true, okay? So that's another way to prove that that is no solution. Okay, let's roll this screen up here, and we're going to do 7 and 9. So 7, we have 2x, we have some distributive property. We're going to do this, 2 times 4x and 2 times negative 3. So this is 2x minus 8x and then plus 6. On the other side, we have 6 minus 6x. So let's combine some like terms here. 2x minus 8x is negative 6x. Okay, so let me use a different color so I can show that. Whoops, we zoomed in a whole bunch. Okay, so this and this are on the same side and they are like terms, so we need to combine them, okay? So what happens is we get negative 6x plus 6, and on the other side, we have 6 minus 6x, okay? Now, you could also rearrange the terms on the other side, because keep in mind, this is its own term, and this is its own term. And if you rearrange them, you get minus 6x plus 6. So aren't the two sides completely equal to each other? And the answer is yes, they're exactly the same thing. So it does not matter now what you plug in for x. You can plug in anything for x, and you'll get a true statement. If you plug in 0 for x, you're going to have 6 equals 6, and that's true. So because that's true, you have infinitely many, did I spell that right? Infinitely many solutions. Oh, obviously I need to write the word many, so let me fix that. Hold on, please. Just move that out the way. Infinitely many solutions, okay? All right, last problem here. This is actually a literal equation. There's no numbers that we're solving for here. All we're trying to do is get the h by itself. So we're trying to rewrite all the terms in this equation so it's h equals something. That's the whole point of this. So I want to try and get h by itself, and I'm going to do all the same things I've been doing in all the other equations in order to move this stuff out of the way. So first thing, I want to get rid of this fraction. So I'm going to multiply both sides by the reciprocal, which is 2 over 1, okay? I'm probably going to need to make some space here. So A equals 1/2 base times height. That's what this equation is. It's the area of a parallelogram. So basically, you need to multiply both sides by 2. So this whole quantity times 2 over 1, and this whole quantity times 2 over 1, okay? And when you do that, I want you to pay attention because, I'll switch colors, 2 over 1 and 1/2 will cancel each other out. They are reciprocal, so they cancel out. And on the other side, 2 times a is just 2a, okay? And that's the part that seems to get kind of tricky for you guys, is multiplying the variables with the numbers. But you got to just think about it in terms of 2. If this was a number, if a was a number, then you would literally just be doing 2 times that number divided by 1. So it's going to be 2a equals, all I have left now is base times height, okay, b times h. Now to get h by itself, since these two things are being multiplied, I have to do the opposite operation, which is division. So we're going to divide both sides by b. And notice when I divide both sides by b, this b cancels out. So what I have left, I'm going to draw an arrow here, is 2a divided by b equals h. And this equation is done. I've solved it. I've gotten the h value by itself. This is what I was trying to do. That's what that means, solve for h. Okay, so you guys go ahead and do 2, 4, 6, 8, and 10 on your own as practice. And I'm going to move on to the next topic. So if you want to pause the video here, this is a good spot to stop and do some of those practice problems. Okay. Next section is about inequalities. So we're not only going to solve this inequality, we're going to use a number line to graph our solution or our possible solutions, okay? Now, I'll explain it as we go, so don't be scared, all right? So we need to get the x by itself, and to do that, we need to do the opposite operation, which is taking away 13 from both sides. This will cancel out, and all you'll have left is 11x greater than or equal to negative 33. Okay, you also need to get the x by itself here. That's the goal. So you want to do division to divide both sides by 11. And this will cancel. And all you will have left is x is greater than or equal to -3. Now, I know you're thinking, what about that rule that says that you have to flip the sign? Remember, the flipping of the sign only happens when you multiply or divide by a negative. So this time we divided by a positive 11, so the sign stays the same, okay? So now that we know this, what this literally means is that this x is greater than or equal to -3. That means x is anything -3 or larger, okay? So since there's multiple things that x can be equal to, we represent our answer using a number line. Okay, now remember, you also have to think about the circle, right? So if your equation has, and I'll make note of this, I'm actually going to do this at the top of this page here. If it's less than or equal to, it's an open circle. Okay, and this has to do with this inequalities right here. And then the other thing is, if it's less than equals to or greater than equals to, it's a closed circle when you graph it. So that's the only really two questions you have to ask yourself is, do I use an open or closed circle? And then do I color the line above or below? So let's go to -3. It's right here. And it's a closed circle because this is greater than or equal to. So at -3, we're going to draw a big closed circle. And then since x is greater than -3 or equal to it, the shading is going to be to the right. Because this means that it is greater than or equal to. Okay, and that's it. That's the answer. You do the same process for all of these. So let's go ahead and dive into number 2 here after I take a little sip of some water. Okay, so number 2 says we have to get the x by itself. So let's do the numbers first. Take away 6 from both sides. This cancels out. You have -2x greater than 3x minus 40, because -34 minus 6 is -40. And then you have to get the x's on the same side, so we want to subtract 3x from this side and subtract 3x from this side. And you end up with, sorry, I used some lines here. You end up with -5x less than or equal to -40. Now, I might run out of space here. I'm going to try not to, but you have to get the x alone, so now you need to divide. So you're going to divide this by -5 and divide this by -5. So this cancels out. And then what you have left here is x greater than 8. Careful, okay? Notice how the sign, okay, so I just completely lied to you. Sorry, let me erase this. It should be less than. So this sign was greater than before, correct? And when you divided this by a negative number, okay, that means you flip the sign. So now the sign is less than instead of it being greater than. So we need to go to 8. Is this going to be an open or a closed circle? It's going to be open because this is less than. It's not less than or equals to. So at 8, we're going to draw an open circle. And then since x, the value of x can be anything less than 8, the shading is going to go to the left because it can be anything of these values over here on this side all the way to infinity because all these values are less than 8. Okay. 3 and 4 are for you guys. So I'm going to do number 5 because number 5 is just a little bit different. Okay. So let's go ahead and process this. We have an OR. So that means we have 2 separate inequalities that we need to solve for here. And what this is, it means that x can be in 2 different ranges, okay? But there's going to be a range of values that it absolutely is not a part of, and you'll see that when we do it on the number line. So let's solve the first one by taking 7 away from both sides, and you're going to get x is less than or equal to -5. And then draw a line here because you have an OR, okay? The other side, you need to take away 5 from both sides, and all you're going to have left is x greater than or equal to -2. So there's two possibilities here. X, the value of X, can be anything less than or equal to -5, but it can also be anything that's greater than or equal to -2. So these are both going to be closed circles. So let's do the first one. At -5, we're going to do a closed circle. And the values of X are less than -5, which means I'm going to the left for less than. And then my other inequality is X is greater than or equal to -2. So you go to -2, it's a closed circle. And then you go to the right because it's greater than or equal to -2. So X can be any of the values that are in this area or this area, but they cannot be anything that's in between that, okay? Number 6 is a similar problem, so go ahead and work that one out and go ahead and plot your answer. This is a good spot to pause your video if you would like to give that a shot, and then come back and we'll do the rest of the worksheet. So the last section on here is going to be using algebra to solve word problems. So we have 2 word problems. I'll do one and then you'll do one, okay? Max is making a rectangular garden that is 5 feet less than twice its width. If the perimeter of the garden is 80 feet, what are the dimensions? So what they're asking for when they say dimensions is they want to know what's the length of the garden and what is the width of the garden. I know there are only 2 dimensions here because they told me that it's a rectangle, and a rectangle is a 2-dimensional figure. So let's draw a picture. Here is our rectangular garden, and let's see, it's 5 feet less than twice its width. So if this is the length and this is the width, then that means the length is 5 feet less than twice its width. So this is going to be 2w minus 5. Twice the width minus 5 is this side, and then the width is going to be this side. The perimeter is when you add up all the sides together. So you're going to have w plus 2w minus 5 plus 2w minus 5 equals 80 feet. So all of that added together is going to give me the perimeter of this rectangular garden. So now we just need to combine these like terms, and then we can go ahead and solve this. So this is going to be w plus 2w minus 5 plus 2w minus 5 equals 80. And I'm going to switch up colors here so we can identify. That's a like term, like term, like term, and like term. And then this is a like term with this. So you need to combine all of these together. Okay, so 2 W's, 2 more W's, that's 4 W's, 5 W's, 6 W's. So 6 W's. If you combine minus 5 and minus 5, you get minus 10. And that's equal to 80. Now we can solve this and find the width. So we're going to add 10 to both sides. 6w equals 90. And then we just need to divide both sides by 6 to find out what w is. 90 divided by 6 is 15, if I'm not mistaken. Yep, 15. Okay. So now we know that the width is 15, okay? Now, they asked us to find the dimensions. That's what the problem is asking for. So please be careful when you're reading these, because you want to make sure you're giving them all the information that they're asking you for, not just part of it, okay? They want to know what's the dimensions. So I'm going to switch colors, and let's make like a little answer box over here. The width is 15, and then the length, remember the formula to find the length is twice the width, and then you take away 5. So twice the width, okay, is 15 times 2, which is 30, and then you take away 5 from that, which is 25, okay? You can also double check your answer if you want to, just to make sure that it's logical. So if I have 2 L's and 2 W's, so 2 lengths and 2 widths, that's going to be the whole perimeter, and it should add up to 80. So 25 and 25 is 50, and 15 and 15 is 30, and 15 plus 30 is 80, and that's how we know our answer is right. Okay, so you guys go ahead and do number 2. That's going to be the last practice problem you have for the classwork for this assignment. Just so that you guys are on track here, this assignment today, you're going to have a grade for the notes that you turn in, which is what we've done together. You're going to have another grade for doing the practice problems on this worksheet and turning that in. And also, you have a Delta Math assignment that comes with this, and it goes over the topics that are inside of this lesson. Okay, so that's all I have for you guys tonight, and if you have any questions or anything, just shoot me an email or come to my Google Meets on Tuesdays and Thursdays. When I post that code, you can pop in and see me, and you can get your questions answered. All right, I'll see you guys later. Thanks. Bye-bye.